Hey, thank you. Hey, thank you, everyone. First talk, kind of nervous, but let's get this through. So, welcome. My topic today, to infinity and beyond, serverless scaling with AWS Lambda. Does any one of you know AWS Lambda? Maybe raise your hand. Okay, so maybe a fifth of the room. Okay, so AWS Lambda is an Amazon product, as you can tell by its name. And this talk is not about developing some microservices. It is indeed about robot framework. So this talk is about having an experimental approach how to run robot framework on AWS Lambda in a highly parallelized way to speed up your test execution. And it shall show you how to run things on Lambda, help you to get started and do your own experiments. So beside this talk, I also created this GitHub repository. You can find it here behind the QR code. I will also show it in the end. And there you can find my source code, so everything I created, along with some nice documentation. And if you need any help, you can always reach out to me. Before we dive into the talk, a few words about me. So my name, Mani Kasiria. I'm from Germany. But my father is from Iran, so that's why my name doesn't sound like a real German name. As a job, I'm a QA engineer at DB Schenker, so that's a global freight forwarder. And there I educate people about Robot Framework. I'm also a Robot Framework Foundation board member, now in the second term. And it's the third time I speak here, but I finally made it to Helsinki, so it's great to be here and see you all in person. So let's start with the problem I had before I started working on this serverless automation thing. So what to do if your test suites grow? Not sure if some of you have experienced it. When you start a new test automation project, you start small with a few test cases. But of course, those test cases, they grow over time. Especially if you do things like data-driven testing. Yeah, the number will explode after a while. So you will have a lot of test cases and, of course, a long execution time. So this will grow along with the number of tests. The question is, what to do then? You can accept the longer runtime. So that's an easy solution. You do nothing, you'd have a later feedback. Or you can run things in parallel, for example, using Parbot. Any one of you using Parbot in your, at least a quarter, half? Yeah, okay. It's an amazing tool. If you want to run things in parallel quickly, check it out. Developed by Mikko Korpara. It's an amazing tool. After that, it gets a bit more complex. So you can parallelize in different ways. You can start splitting up your test suites, distributing them to multiple machines or pods or jobs, and afterwards merge the results. So it gets kind of complex after a while. So I was wondering, is there a way how I can just say, do the usual, but run it in 1,000 parallel instances? And where to get those 1,000 instances, those 1,000 machines? And this leads us to AWS Lambda. Now, AWS Lambda is an Amazon product, and it's advertised as serverless, event-driven, and scalable. And I don't want to advertise Amazon. There's other cloud providers offering similar products. So if you look at Google, I'm pretty sure you will find something similar, but I wanted to play around with Amazon stuff, so I used that one. Now, those terms are all buzzwords, kind of. So let's look what they mean. It's serverless. That means you don't need to worry about infrastructure or machines. What it is, it's a service where you just bundle your code together with your dependencies, you give it to the service, and you define a trigger. And when this trigger occurs, your code will be executed, so a so-called Lambda function will be there. It will do its stuff, and then it will disappear. And you only need to pay for the execution time. You don't need to pay for a server or for the maintenance. You just pay for the pure execution time of your code. And for me, from a test automation point of view, this is an interesting concept. I also have a little pricing example here. So if you run your test automation for an hour on AWS Lambda, it will cost you 6 cents. That means you can do daily runs of 8 hours for $14 a month, just to get a feeling for the cost. Second thing, it's event-driven. That means you will define something which will trigger the Lambda function. It won't be there before, but when this event arrives, it will be there. And you have a lot of different choices for those events. It can be an HTTP request, like a GET or a POST to a certain endpoint, and this will trigger the Lambda function. It can be an S3 bucket event. An S3 bucket is a storage thing in Amazon to store your files. So basically, when you store a file there, it will trigger a Lambda function. You can also do things like asynchronous processing. You can use message queues. So when you put an item into a message queue, it can also trigger a Lambda function. And there are more ways. As you can see, you can have database triggers, you can trigger Lambdas on a schedule, or even one Lambda function can trigger another Lambda function. So those are the things which can start the execution. And the last thing, it's scalable. That means when you call it, it will be there all of a sudden. And when you call it often, it will be there often. And the scaling is automated. It can, by default, go up to 10,000 instances. Yeah, you can, of course, reduce it. You can even increase it. And it depends on some factors. Of course, it depends on how often you call your Lambda function. So when I call it once, of course, it will only scale to 1. But if I call it like 1,000 times, it won't exactly scale to 1,000, but it will definitely scale higher. Maybe 50, maybe 100. Also depends on the runtime of your Lambda function. But the core thing is, it will scale automatically. And this is pretty nice. So those are the 3 basic points about Lambda. And now that we know that, let's do a little magic trick in the morning. So I will try to make something disappear. I will try to make time disappear. So how does that work? Well, the setup of the magic trick is the following. We have a keyword, a long keyword, 60 seconds, asleep. I mean, very simple thing, but there's no way to escape those 60 seconds execution time. Now we have that keyword in 600 test cases. So I'm wondering, how long would the execution time be? You can do the math, 600 multiplied with 1, 600 minutes, 10 hours. So if I would start such a test on a single machine, it would still be running when the conference day is over here. Now let's do our magic spell. And the spell was done by ChatGPT, but it was still better than my spells. It goes like this: by the power of Lambda, robot framework tests be done. Sounds like Italian, I don't know, but it was still better than mine. So, of course, that's not all. So here it goes. So first part, by the power of Lambda. What we do here is we do a post request. We do a post request to a certain endpoint, my Lambda endpoint. And inside the post request, inside the body, we put in some data. A project, demo, a tests folder that shall be executed, tests, a run ID, RoboCon, and shards. We will talk about that later. But this is basically the number of pieces I want to break up my tests folder into. 600 pieces of equal size. We do that, we get back a response. Test run, RoboCon created. No magic yet. Second part of the spell, robot framework tests be done. Here we do a GET request to the same endpoint. This time we provide some arguments in the URL. Again, the project name and the run ID. Now we get back an interesting response. We get back as a response the number of passed tests, failed tests, and the total number of tests. Beside that, we also get back some URLs where we can download a report and some Allure results. Still, no real magic. It's robot framework somehow in a web service or something like that. Okay, so let's have a look at the report that we got back here. That's a normal robot framework report. what we see here, total execution time at the top, 10 hours. Yeah, nothing unusual. Time per test, 1 minute. Also nothing unusual. However, when I check the Allure report, there's something strange. If I check the Allure report, do you know Allure, by the way? Does anyone know Allure? Can you also raise your hand? Okay, only a few people, maybe fifth of the room. Okay, so it's another reporting framework. So you can basically create Allure reports out of a lot of different testing tools. However, it doesn't matter. But what this report shows, the real execution time was around 6 minutes. Yeah, 6 minutes, 17 seconds instead of 10 hours. That's around 1% of the expected execution time. What happened? Some magic? Or did I play a trick? So let's see what happened in the background. In the background, there were 3 Lambda functions doing all the work, together with some other Amazon components. And I would like to introduce the 3 Lambda functions to you. So they are called the distributor, the executor, and the merger. And they do exactly what their name says. So the distributor is the first Lambda function in the row, and we send our post request to the distributor. What it will do is it will break up your tests into smaller pieces, into small packages, and it will hand over those packages to the executor. Now the executor is responsible for the test execution, as you can tell by its name. So the executor will run each small test chunk, only the small chunk, not the whole folder, just the small chunk it received. And then there's the merger. Now the merger will take the results from the executor. So those mini XML files the executor produces, and it will merge them all together into a full report, which it will send back to you as a response. So that's the thing on the high level. So let's go a bit deeper and have a look what the distributor is really doing. So it's not only a Lambda function which is doing the work here, it's several Amazon Web Service components. It all starts with the API gateway. And this is a place where we get our post request. Yeah, so it's all triggered by this post request that I showed in the magic spell. In the post, as I showed before, we provide a project name demo, a tests folder, the number of shards, so the pieces it should be split into, and the run ID RoboCon. This HTTP post will start the distributor. What it will do is the distributor will download a demo folder from an S3 bucket, the tests bucket. So this is a place where we store our testware. So whenever we want to run it that way, we need to make sure our tests are stored on this S3 bucket. Now the distributor will download those tests, so it has them available locally, and now it will start its work. It will split up those tests into smaller pieces. In reality, there will be some robot framework listener running in the background. It will use the pandas library, and it will do some clever splitting up, and it will try to split up your tests into equal pieces, so 200 pieces of equal size. After it split up the pieces, it will send them in a message queue, in an SQS message queue, and this message queue leads to the executor. Now, what's inside each message? It's again the project name demo, again the tests folder, the run ID, and now for each small package we have a job ID. So each of those 200 pieces gets a job number. For example, job 1, 2, 3 until 200. And each job will only have the test cases that it shall execute. So if we divide 600 tests by 200, each job will have like 3 tests inside. So 200 packages with 3 tests each. And this will be sent to a message queue. Last thing the distributor does, it will update an entry in a database, in a DynamoDB database. It's a small database at Amazon. And it will track the status. of each of those jobs in there. By default, it's in progress. And now this leads us to the executor. So the executor will now read the things from the message queue. So it all starts with the small package we get from the message queue. Again, only with those 3 tests we want to execute. And this will trigger the executor Lambda function. Lambda function will start its work, and it will again download our testsware from the S3 bucket. So it has the test cases and resources, everything available. Then it starts the execution of the tests. However, only the 3 tests which are part of that package. It doesn't execute the whole folder, just a small piece which was part of your package. After execution is done, the results will be written to another S3 bucket, the results folder. So you will have a small XML file there for each job, together with the screenshots and Allure results and everything which is part of the normal logs. Last thing it does, it will again update the job status for each job. So it will set now this small test job to execute it. Now, the interesting thing about the executor is it scales. So that means when a lot of small packages are incoming from the message queue, it will not run as a single instance, but it will run as maybe 10 instances, 20, 30, 50, depending on the number of things which are incoming. So it will scale automatically. And this is the thing which speeds up the execution time in the end. Now, when all jobs are executed, the executor will check in the database, was this the last job from this run ID? If it was the last job, the executor will trigger the merger. So this Lambda function will trigger another Lambda function. And here in the trigger, again, the project name demo is provided and the run ID. And this will lead us now to the merger. So the merger is responsible for merging the results. And, yeah, sorry, it's a quick slide. So it will now be triggered from the API gateway via the GET request, that's what I did in the magic spell, or it can be triggered from the executor. So we have multiple possibilities to run this merger. Now, when the merger starts its work, it will download the results from the results bucket. That means all of those small test results from each job will be available in the merger. Then the merger will merge all of those XML files together and create a report for us, like a proper robot framework report. And it will store this report in the results bucket in a folder final. Then, almost done, it will update the job status. So after all jobs have been merged, it will be set to merged. And this is like the final status inside this database. And then the last action is it will return the results back to us in an HTTP response. Yeah, so you get the job status, the number of passed and failed tests, and some download URLs. So that was the intro on a high level. And you might wonder, okay, some slides, what is under the hood here? I can show you a little bit. Yeah. So this whole thing is written in the so-called SAM. This is the Serverless Application Model. It's a standard from Amazon which allows us to define infrastructure as code. Because as you saw before, it's not just a Lambda function we have. We have a lot of resources we need to set up here. The S3 storage, the message queues, the databases. Yeah? And of course, I don't want to use the Amazon Web Console to set up that stuff. I want to write it all in a single file structure so I can build and deploy the stuff easily. And that's what this SAM model is good for. So it allows us to define all of our Amazon resources in a YAML file, which I will show later. It's a template YAML. So it will allow us to define everything there. Then in the folder structure, you can see each Lambda function has a folder. The distributor, the executor, the merger. So this is where you store the code of each Lambda function. In our case, it's some Python code. You can see this app py. So this is basically there's the code of the Lambda function inside. You can also see there are some requirements files for the distributor. Or in the executor, you have a Docker file. So this is how you manage your dependencies. You can either define them in the requirements file, or you can even create Docker files, which will result in Docker images. Yeah? So you can bundle all your dependencies in there. And when you set up this structure, it will allow you to deploy things easily. It's just 2 commands. SAM build, and this will package your Lambda function, your resources, create your Docker images, and then SAM deploy. And this will deploy your stuff to Amazon. It's a pretty straightforward setup. Now, in the last few minutes, let's have a quick look at the template YAML, so we get a feeling of how this infrastructure as code works with this SAM. So here are some examples. In the top left, you can see how this message queue is defined. Yeah, this test job queue in the YAML. And all which is needed to define this message queue is basically the name, test job queue, and the type, AWS SQSQ. The other thing there, this timeout, is optional, isn't even needed. But that's all which is needed to tell Amazon, please create a message queue for me with that name. Similar for the S3 buckets. You can see below the test job queue our S3 buckets. Test bucket, results bucket. Again, it's only the name and the type of the resource which we need to describe there. For the Lambda function on the right, I just put in some code snippets from the executor and distributor. It's a bit more. Yeah? So you also need to define the type here. It's an AWS Serverless function. This tells Amazon this is a Lambda function. And then you need to tell Amazon, is this based on a Docker image? Then the package type is image. Or is it based on some Python code and a requirements file? Then you need to provide the folder where this is stored. And of course, I cut away a lot of stuff there. So Lambda function is a bit more complex. But that's not the main point. The point is it's much easier to describe your stuff as code instead of clicking around in Amazon console or stuff like that. And the nice thing about this structure is you define all those stuff in one file, and the resources can reference each other. That means you can define this test job message queue at the top left. So you define it there. And then you can say in the Lambda function, I want to have this message queue as a trigger. Yeah? So you can say in the Lambda function, this events section, please take my message queue as an event for this Lambda function. Yeah? So you can reference the resources there. Same for the test bucket. You can create a test bucket and later hand over the name as an environment variable. So we can later access this S3 bucket very easily from your Python code. Yeah, and this is pretty powerful because it allows you to describe everything in a single file. Now, for the closing, I also hit some limitations. This was all an experiment for me, playing around with AWS. So here are some limitations or some obstacles that I hit. First, the timeouts. And this was a bit annoying. So the Lambda functions have a timeout of 15 minutes. That means if your single tests run longer than 15 minutes, this approach is not for you. Yeah, so the Lambda functions will time out. They will run maximum for 15 minutes. Even worse, the API gateway timeout of your HTTP request. This is 30 seconds. So you can't just trigger a long Lambda function and wait for it. You need to do it asynchronously somehow. That's why I split it up into multiple functions in the end. Then some size limits. If you package your dependencies of your Lambda in a zip, you have a 250 megabyte limit. And while this sounds like a lot, when you use things like the browser library or other more complex Python packages, you will hit this limit rather quickly. Then you need to use this Docker image approach. There you can use up to 10 gigabyte of storage. Then also some space limits. So there's a temp folder on each Lambda function which can fill up quickly. You need to make sure to clean it after each run. And in the dependencies, in this Docker image approach, this Docker image is normally based on Amazon Linux. Yeah? And while this works, sometimes you need to install some additional dependencies in there. I got browser library working with that approach, but you need to install some more things. And the last one, you need to consider time is money, memory is money, and storage is money. So you want to reduce your Lambda function as much as possible when you write it like that. And this brings us to the end. So as I said, you can find more documentation there. And now it's time for questions. And if you have more questions later, just find me in the speaker's corner. So thanks a lot.